Which of the following covalent bonds has the greatest polarity? So when you talk about the difference in polarity, it's difference in electronegativity value. So what you do is you just look up the values. So like if you look up Br, for example, Br minus Br is 2.96 minus 2.96. That's obviously going to be 0, right? So when we look at it, we do sulfur. Sulfur is going to be 2.58, and oxygen is 3.44. You would subtract those. Carbon is 2.55, and then I look up carbon. Oh, carbon's 2.55. Oxygen is 3.44, and boron is 204, and oxygen is 3.44. So when it asks you greatest polarity, it's greatest difference. So you can see when you look here, obviously it can't be that one. 3.4 minus 2.58. See how you have 3.44 minus 2.04? That means that's going to have the greatest polarity, the greatest difference. So when you subtract the two of them, larger minus smaller, that has the greatest difference. Next one, if you look at second problem, is the number of lone pairs in an N2 molecule. So when you're talking about lone pairs in an N2 molecule, you first have to draw it. So we go N, and N2 is going to be 5 plus 5 is going to be 10 electrons. So I'm going to go N, line, N. I just used 2. I have 8 left over. I need 6 here and 6 here, which is going to be 12. So that's going to be minus 4, which in this case would be a triple bond. I would add a pair there and a pair there. So then when I'm looking, when it asks me lone pairs, it's dots, not lines. So then the number of lone electron pairs in the molecule would be 1, 2. So you have to, in order to identify lone electron pairs, you have to draw a Lewis structure, and you're looking for the dots, not the lines. Next one. Complete dot formula of AsCl3. As has 5 valence electrons. Chlorine is 7, 7, and 7, which is going to be a total of 26. So I have 26 valence electrons. I'm going to go As line, Cl line. I'm going to go minus 6 is 20 remaining electrons. Then when I go and look at needed, it's going to be 6 here, 6 and 6 for the outside. This has 2, 4, 6, so it only needs 2 more. So 6 plus 6 plus 6 plus 2 is going to be 20. 20 minus 20 is 0. So all single bonds. So then I just rock the dots. So I have the dots in here, dots in here, dots there. And then it says, the question's asking me, what does the formula show? Well, it's not 1 single, 2 doubles. You can get rid of that. 2 singles and a double, I get rid of that choice. 3 singles and 10 lone pairs of electrons. That looks like that might be at 1, 2, 3. And then it goes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Bingo. We have a winner chicken dinner. All right, next. Which of the following Lewis formula is incorrect? The easiest way to tell an incorrect Lewis formula is to check to see if they all have 8. Now remember, hydrogen only gets 1. So hydrogen will never, as long as it gets a line, it's good. This has 2, 4, 6, 8, so that's good. When you look here, 2, 4, 6, 8, and that's the same thing, so that's good. Here, 2, 4, 6, 8 for carbon. I don't really pay attention to hydrogen, it doesn't matter. When I come over here, same thing, that's good. If I look over here, this has 2, 4, 6, 8. This has 2, 4, 6, 8. But how would you? Oh, the total number of dots. You would have to total the valence electrons. So like here, it would be 5 plus 5 is 10 valence electrons, right? So it can only have 10 dots. You use the dot thing first to check it. See how this is only supposed to have 10 total pairs? It's got 2, 4, 6, 8, 10, 12. So it has more dots than it's allowed to have. So what you would do is, when you go to do it, before you even start checking these, like when you go here, carbon has 4, plus each hydrogen is 1, 4, so it has to show 8 total electrons. That's probably the better way to check. But you can also check by seeing whether or not it has 8 or not. So you would do that. Which of the following compounds does not follow the octet rule? You have to know the exceptions. When you know the exceptions, you would obviously know phosphorus has 5 atoms around it, phosphorus the prosperous. C would be the correct answer based on that, so be aware of those. Which of the following has a molecule with an incomplete octet? Again, it goes to the 4 that you have to be aware of. Here they are. Is what? Boron, unless it's an ion, very rare, bonds on 3 sides. Beryllium will bond on 2. Phosphorus can bond on up to 5 sides. That's when it's basically like PCl5. Sulfur can bond on 6, not always, but it can. So if you see S with 6 after it, you know those are exceptions. These all violate 8. This only has 6. That has 4. That's going to have 12. That's going to have 10. So those are all violations of the octet rule. So look who I see right there. That's memorization via 3. I know it's going to violate it. Use the Vesper theory to predict the shape of NH3. So the first thing you're going to have to do is you're going to have to draw it. So when we go to draw the molecule NH3, we do this. You're going to go, okay, you're going to go N, line H, line H, line H, and then dot, dot. When you go to do a species formula, A represents the central atom, so this is A. X represents atoms directly connected, so I have 1, 2, 3 atoms connected, and then E represents pairs of dots on the central atom. So this is going to be AX3E, which the shape of that, memorize-wise, is you have to memorize it as a pyramid. Use the Vesper theory to predict the shape of CI4. So when I go to do that, I would do carbon, I, and I would draw the dots. Obviously, you can draw the Lewis structure, so you draw that. And then it has a central atom. It has 1, 2, 3, 4 atoms attached to it, so it's AX4. AX4 is represented by the shape tetrahedron. So it is a tetrahedral. In case you're wondering, the bond angle is 109.5 on a tetrahedron. All right. Predict the shape of ClO3-. So when we go to do it, Cl has 7, O is 6, 6, and 6, and the charge is -1, so we add another one. So it's going to be a total of, what is that, 18, it's going to be 24. So you get 24, so 18 plus 8, 26. I mean 26. So it's 26 valence electrons right there. So when we take a look at it, we go Cl, line O, line O, line O. I just use 6, which means I have 20 remaining electrons, and then I have to figure out how many I need. Outside's always going to be 6, 6, and 6. That's going to be 2 because it's got 2, 4, and 6. So then it's plus 6 plus 6 plus 6 plus 20 is 20 minus 20, which is going to be 0. So then when I go to draw it, she wants the shape. So we do this. I go to do the species formula. A is my central atom. I have 1, 2, 3 atoms connected, 3, and I have 1 lone pair of electrons, so it's AX3E, which the shape of that is going to be a pyramid, because AX3 is always a pyramid. A pyramid's bond angle is going to be 107 is the bond angle on all those, in case you were wondering. Next one. Shape of H2SE. SE has 6 hydrogen. There's 2 of them, so a total of 8. So I go SE, line H, line H. Then I basically use 4. So 8 minus 4 is going to be 4 left over, or remaining. I only need 4 here because hydrogen's good. So it means it's all single bond, so I rock the dots. Remember when I'm adding lone pairs of electrons, if I add 2 pairs, they have to go on the same side because that molecule is going to be bent. We show that molecule as being bent, so you basically show it like this. Pair there, bent like that, H like there. So then the species formula would be AX2, because there's 2 atoms connected, E1, 2, and that is going to be bent. So that molecule will be considered bent on that. And there you go. Next one, SiO2. Si has 4, O is 6, and 6. I get a total of 16 valence electrons. I go Si, line O, line O. It's going to be -4. I'm going to get 12 remaining electrons. Then I go to do needed. 6 and 6 on the outside always. That's going to be 4 because it has 2 and 4. So 6 plus 4 plus 6 is going to be 16, which leaves me with a -2. -2 is either 2 double bonds or 1 triple. In this case, if I can, I want to make it symmetrical. I add that. Then the last step is make sure everybody gets to 8. So if I look here, I go 1, 2, 3, 4, 1, 2, 3, 4. and that is my molecule. So when I go to figure out what the shape of it is, it's going to be AX2, so 1, 2, which means that molecule will be considered linear. Okay? It is a nonpolar molecule as well, because remember, if it doesn't have lone pairs of electrons and the atoms on the outside are all the same, the molecule is automatically going to be nonpolar. Let's see here. All right, next, when we look here, it's asking you a nonpolar molecule. Which of the following is a nonpolar molecule? Well, if we look here, this is HCl. If you only have 2 atoms that make it up and they're different, it's automatically going to be polar. So that's automatically polar because it's 2 elements and they're different. It's going to be polar. Water, which you should kind of know already just off the top of your head from bio or whatever, that's water. Water has lone pairs of electrons, which is automatically going to make that polar. Can't be that one. When we get to CO2, this is what CO2 looks like. First question, does it have dots on the central atom? No. Are the terminal atoms different? No. Then that sucker is nonpolar. C is your correct answer. D, if you look at D, here's what D looks like. D is going to be N, line H, line H, line H, dot, dot. That molecule is going to be polar as well. So when they ask you the nonpolar molecule, you're looking for a molecule with no dots on the central atom and all the atoms on the outside are the same. Which of the following compounds is most likely to be covalent? Covalent means nonmetal plus a nonmetal. The trick is you find the one that has a nonmetal as the first element. Because if you write it, the way you have to write an ionic compound is you always have to write the metal first. So if we look at that one, that one, that one, that one, and that one, the question really is, when it says covalent, you're asking which element is not a metal. K, that's a metal. Ca, look where it is in the periodic table. It's on the left-hand side. Metal, ding, 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 winner, winner, chicken dinner. If you look where sulfur is in group 16, so it's a non-metal, so that automatically makes that covalent. Which of the following is a polar bond? Well, the definition of a polar bond is you got to be greater than 0.4. I think they said 0.4 to 0.17 is a polar bond. Anything past there, I believe, is ionic. You have to look at your chart. That would be polar. So when you look at it, I'm going to change that statement. It's 0.41 to 1.99. I believe they told you in honors. That is going to be a polar bond. So that would fall between them. If its atoms are the same, automatically you know it's going to be 0 because the value of Cl minus 0, Cl is going to be 0, 0. So I automatically cancel those. So then I'm looking at these 3. So then calcium, when I look at the value of calcium, calcium is going to be 1.0. Chloride is going to be 3.16. So that's going to be 2.16. So it can't be that one. NaBr, Br is 2.96. Na is going to be 0.93. That's going to be greater than 1. That's going to be greater than 2, actually, when you do that. Was that 203? 203. 203. And then finally, it's got to be E. When you take the values, this is just subtraction. You learn this in like 2nd grade. 3.13 minus 2.19. Bingo, right there. You're going to be left with 1.03, which falls in the range of a polar bond. You're just subtracting the larger number from the smaller number. Hold on, it's going to be this one. Apparently, I looked at my numbers wrong, or I can't subtract. I'll have to go back to school. It's 3.16 minus 2.19, which is going to be 0.97. Either way, it has to fall between the range of 0.41 to 1.99, and that falls in the range. That's a polar bond. If it's less than 0.4, it's nonpolar. If it's greater than 2, or 2 or greater, it would be ionic. So this would fall under the category of a polar bond. It's just knowing the differences. All right, next one. It says the structure of a Lewis structure of ClO3 minus, which I think we drew already earlier. We did draw it. ClO dot 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 dot. Box it because it's an ion minus 1. They ask you how many single bonds would it be. You would have 1, 2, 3 single bonds. So that can't be an answer choice. That can't be an answer choice. That can't be an answer choice. How many double bonds would it be? It would be 0 double bonds. So that's a single, single, and single. So 0 double bonds. And then finally, how many lone pairs? 2, 4, 6, 8, 10, 12, 14, 16, 18. Wait, it's pairs. Let me try that again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 pairs. So D would be your correct answer because you're counting dots. So 2 dots is a pair, and then basically you're breaking down them. Which is a Lewis structure that doesn't obey the octet rules. We're looking, remember there's 4 weirdos. The periodic table. You see phosphorus to prosperous right there. 2 atoms with an electronegativity difference of 0.4 forms a bond. It's right on the borderline. We say it's nonpolar according to the scale because 0.4 below automatically is nonpolar. What is the shape of the molecular geometry of NH2 minus? So when we look at it, let's draw this. We go and do it. It's NH2 minus 1, so it's going to be 5 plus 2 plus 1 is a total of 8 valence electrons. So I go N line H right there. So how many did I use? I used 4. I have 4 remaining, and how many do I need? This only needs 4. So I add the dots. But remember, when I add the dots, if I have double pairs, I have to bend the molecule. So it's going to be N, this, like this, 1, 2, 3, 4, like that. And then what's the question asking me? Oh, what's the geometry of it? A is the central atom. X represents the terminal atoms. So AX2, 1 pair, 2 pairs. E2, that shape is going to be a bent molecule. What does Vesper mean? Vesper means electrons repel each other. So what happens is, because electrons repel each other, like these electrons always push away, it makes the shape of a molecule. So the repulsion of electrons, see where it says repulsion of electrons, the E in there is repulsion of electrons, helps determine the shape of covalent molecules. That's the little Vesper theory. Is B is your correct answer right there. It's just knowing the definition of what the Vesper theory is. Hold on. Let's see. What is the measure of a tetrahedron bond angle? You have to know basically it's 109. If you think about a tetrahedron, think about it like this. This is a horrible 3-dimensional drawing, but imagine this. A tetrahedron has a bond angle which is 109.5. Every time you add a lone pair of electrons, you basically reduce the bond angle by 2.5 degrees. So like if I put a lone pair of electrons here, they're going to push or repel a little bit more. So you just subtract 2.5 degrees. So when it's AX3E, the bond angle is 107 degrees. That's how it works. So lone pairs of electrons basically affected by about negative 2.5 degrees. How many electrons are shared in a double covalent bond? In a double covalent bond, it looks like this. Remember, lines just represent how many electrons are shared. It would be a total of 4. So a double bond shares 4, a triple bond shares 6, a single bond shares 2. How many lone pairs of electrons does a nitrogen atom have in a molecule NBr3? When I look at NBr3, I go N, line Br, line Br, line Br. Nitrogen's kind of, you know nitrogen has 5 valence electrons. So whenever you pretty much have 3 atoms around nitrogen, you know it's basically in a lone pair of electrons. If you think about it, because nitrogen, so it'll bond on 3 sides, and they'll have the 2 sticking off. So it'll be like, same thing when you see NH3. You can almost think of NH3 as this. Same thing there. You got the lone pair of electrons here. So it says how many lone pairs of electrons does the nitrogen atom have? It only has 1 pair of electrons right there. Species formula, in case you're wondering, is AX3E. That's going to translate into a pyramidal shape. So that thing's going to be a pyramid, triangular pyramid. Bond angle on that sucker is going to be 107 degrees. It'll be a triangular pyramid.